Well, believe it or not, it's already week 6, and here's some examples from the MyMathLab homework. So this first one, when I first look at that, I think, oh my goodness, this is going to be complicated because we're going to have to plug that into this function with all of this. But then I realized, oh, they just gave us numbers to plug in. So just plug in a 4 right there, and delta x is a 3, and a 4 right there, and a 3 right there. Okay, so that's not too bad. So f of x1 is going to be a 4, plus delta x is going to be a 3, minus f of x1, which is a 4, and divided by the delta x, which is 3. So in other words, that's f of 7 minus f of 4, all divided by 3. And now we use the function and plug in the 7, and then we'll plug in the 4. So when I use the 7, it's going to be 2 and then x squared, or 7 squared, minus, use the function again, 2 and then 4 squared, and it's divided by 3. Oops, sorry, that was a little bit off the screen. And usually I would use my calculator, but I forgot it, so I'll just have to do this myself. Let's see, this is going to be 49, 7 squared is 49, times 2 is 98, minus, this is going to be 16, times 2 is 32, and it's divided by 3. So let's see, a 98, so from the 9 subtract 3, that's 6. From the 8 subtract 2, that's 6. And divided by 3, so that means that it's going to be 22. There we go. Next up, I chose number 4, which says find dy. So when you have some function, like let's just say x squared, and when you find the derivative, you can use the notation dy dx. You could also use y prime, but when we were doing differentials, we use this notation to say the derivative. Dy dx equals 2x. There's the derivative from the power rule. And then the only thing I would have to do is, to find dy, just multiply both sides by dx. So multiply by dx on this side, multiply by dx on this side so that these cancel. And then in this case, it would just be 2x times dx. And then if they gave us some numbers to plug in, we could do that. So that's what they're asking here. Although with this one, I do need to multiply this out first. So for this one, it's going to be y equals, and then x cubed times 8. And when you multiply an x cubed by another x, that's going to be x to the 4th over 3. So then dy dx, or in other words, the derivative would be, so right here, do the power rule. So 3 times 8 is 24. And then subtract 1 from the exponent. And when you subtract 1, that's going to be a squared. Over here, do the power rule. And the 3 can just sit there patiently. The minus sign can just sit there patiently also. So the two of those just wait while I take the derivative of this. So the 4 would go in front, and then subtract 1 from the exponent, and then that's the derivative. The last thing is, they said, what's dy equal? So then dy would mean just multiply both sides by dx, and believe it or not, that's going to be it. 24x squared minus, and nothing can be reduced, so, because they said simplify, but nothing can be reduced, so this is going to be it. And then just put the dx, and it's done. And then off to another fun one. As I click through all the homework questions, here's another one that caught my eye. So again, find dy. So we're going to do the same thing, the exact same thing we just did, but there are going to be some numbers to plug in after we're done. So start by taking the derivative. Dy dx equals, the derivative here would be 2x. So you put the 2 in front, subtract 1 from the exponent, And whenever it's just a number times x, well, the derivative of x is 1, so that means that you're just left with the number. And when it's a number all by itself, its derivative is 0. So we've already found the derivative. And then like on the last one, multiply both sides by dx. And then last, they said plug in a 5 for x, and delta x and dx are always equal to each other. So we're just plugging in a negative 0.1 for the dx. So dy equals a 2 times, substitute 5 for x, minus 9, and then dx is going to be a negative 0.1. So this is going to be 45 minus 9, and 45 minus 9 would be 36. Wish I had my calculator. That's all right. I'm doing okay. And let's see. When you multiply by a 0.1, it changes the decimal from here to here. So it's going to be 3.6 because I'm multiplying by the decimal, and then it's going to be negative. And what else do we have? So this is number 11. This company is going to sell N units of a product, spending X thousands of dollars in advertising. So this is the N between 5 and 35, where these are in thousands. So keep in mind these are in thousands. So in other words, when this says 10,000, that actually means X equals 10 because it's already in thousands. And this means X equals 11 because it's already in thousands. So find dn, and they even put the dx here. So like on the other ones, I would need to type in this dx for the answer, but on this one, they already provided the dx. That saves me typing 2 letters. Thank you, guys. All right, so here's the function. So the derivative, dn, and they already put the dx over here, so I'm not even going to put it. I'm just going to say the derivative of n. Well, when it's just a number in x, the derivative of x is 1, so it's just the number 70. And then minus, the derivative of x squared will be a 2x. And then technically there is the dx just like this. So that's what will go right there, the 70 minus 2x. And then once you answer that part, they're going to say, approximate the increase in sales. In other words, find dn if x goes from 10 to 11. So if x was at 10, and then it changed by 1, so in other words, dx is equal to 1, then you always start with the starting number is going to be x, and I'm actually not using the 11 because the dx is saying if you start at 10 and you go up by 1, that would take you to 11. So the dn is going to be 70 minus 2 times x is 10, and then times dx is 1. And I feel pretty confident I can do this one without a calculator. dn equals, so that's going to be 70 minus 20. And then since it's times 1, that's not going to change the answer. That's going to be 50. And then you do the same thing with a 25 and then a 26. So again, this is a dx of 1 because since it's already in the thousands, we're actually not using the thousands. We're just going from 25 to 26. That's a change of 1. Next up, the egg of a particular bird is almost a perfect sphere, something like an ostrich, because their eggs are very, very round. And the shell, so the radius is 7 millimeters. So they're saying the radius equals 7. And the radius to the outside of the shell is a 7.4. So that's basically saying you have the inside of the shell and then to the outside of the shell. So that's saying that the shell itself is a 0.4, or in other words, the difference in the radius is a 0.4. Then they said to use this formula. the volume equals 4/3 pi r cubed. And then take the derivative. Since this is a number and this is a number, they're just going to sit there patiently while I take the derivative of r cubed. So the dv, and if I do all of the steps, I would put dv dr, because r is the variable, so we're taking the derivative with respect to r. And the 4/3 can wait, and the pi can wait, and then take the derivative of this using the power rule. So the 3 goes in front, and then subtract 1. And then to solve for dv, so the volume is approximated by, so the v, or the difference in the volume, is approximated by, oh, it looks like they're asking this in 2 parts. So 1 would just be the volume. So 1 would just be, for this question, just plugging in the 7 before taking the derivative and seeing what the volume is. And then the dv would be 4/3 pi, oh, I guess I could have had the 3's cancel. Oh, well, I'll do that in just a second. And then times dr. So then these are going to cancel. And then this is going to be 4 pi, the 3's have canceled, and then r is squared, and then multiply by a 0.4. Okay, so like I said, I don't have my calculator with me right now, so just put that in a calculator, round it to the nearest hundredths, so that would be something like 1.23. So they want 2 decimals of accuracy. And then the last one, a promissory note will pay $35,000. So this means that somebody borrowed $35,000 and they're going to have to pay it back 6 years from now. How much would you be willing to pay for the note now? All right, compounded continuously. So that means we're using the PERT formula. And they say that the interest rate is 5.75. So that means that I need to change that to a decimal. Take the decimal, move it 2 places to the left, and that's going to make it 0.0575. And it's basically saying that if it's going to be 6 years, so in other words, t equals 6, how much would you be willing to pay for it? How much would you be willing to pay for it now? So in other words, if in the future it's going to be $35,000, then what's the amount now, the principal, P? If we have E and then 0.0575 times 6. All right, that's the setup. And then to solve for P, all I need to do is divide both sides by E and the 0.0575 times 6 and do that on both sides. So divide by E and 0.0575 times 6. And then these cancel, and then just put that in a calculator. And then it says round to the nearest dollar. So whatever the decimals are, you round it to the nearest dollar.